Thank you all for joining us. We know you guys have busy schedules. Our goal is to provide great information to you guys to help you in your roles, especially with IoT. We're Nabto, and I'm Tarek Hassan, the business development lead here in the US for Nabto. And we have here with us Karsten, our CEO and founder of Nabto, all the way from Denmark. And Karsten is going to be the one who's going to share this knowledge with us today.
Yes, this webinar will be about why latency or 0.1 second matters in IoT. It will be in two parts. The first part will be about why IoT and speed and latency, why that matters, seen from a research angle. Some different thoughts on not only IoT but also user interfaces, basically. And part two will be a short discussion on two types of IoT platforms: the cloud IoT type and the peer-to-peer or real-time communication-based IoT. Before starting part one, let me tell you a short story that kind of visualizes why, without the research, why this is an issue. So imagine you are out shopping, you come home with a lot of groceries, and you park your car, and you step out of the car, you get your groceries, and you go to the door. And it's raining, it's pouring down. You have just installed a new smart lock. You take out your phone, you start up the smart lock app, and now you want to unlock the door. You press the button, and 1 second passes, 2 seconds passes, 3 seconds passes, maybe 4 and 5 seconds passes before the lock opens and you can step inside. That sure would be very irritating. And imagine how long it will be before you will have to install your old type of manually locked door instead. So speed and latency definitely matters in this type of application, and people have actually researched this. They have done some research on it, and I've taken this from somebody called Nielsen and Norman Group, who has actually researched a lot of different things about the user interfaces. And IoT is about user interfaces because it is humans that interact with IoT devices. And of course, one of the first things these researchers has asked is why is this? Why does this responsiveness matter? And they have kind of found out that for two reasons it matters. One is the human limitations, and basically that is that we have a limited amount of memory, short time memory and attention. And basically, when you send out a request for something, so you it doesn't have to be a smart lock; it could be any type of request. If you have multiple requests outstanding, you'll have to keep this in your memory, because when you get the responses for these requests, you'll have to pair them and then say, okay, let's go on. And we just as humans do not have that many, you can say, memory slots for this. And the next thing is human aspirations, they say. So humans just like to feel in control. If you send out a request for some kind of service, the service not responding just can seem arrogant or incompetent, even though it's a computer that you're talking to. And I mean, there's at least until we get AI in real AI or AGI in these IoT devices, they don't act. They act as they do, not because they're arrogant or incompetent, but just because they have limited compute power. these researchers has actually also tried to test out what are these kind of thresholds for human attention, and of course it's not as simple as this here, but the researchers they have kind of grouped different types of human behavior into these factors of 10. So the first factor being you get a response on a request within 0.1 second, so 100 milliseconds. And humans or users, they feel if a user interface can actually act within 100 milliseconds, a user will feel like the system is reacting instantaneously. So you press a button, the button will update. Now the heat in your car is on. If this happens within 100 milliseconds, you'll actually feel, okay, it's like my phone is in instant communication with the car. And you can also think about or imagine, I mean, if you have a movie, a cinema movie will actually play out with something like 25 pictures, and the brain is not fast enough. So these still or single images will actually be fused together as a continuously action happening in the movie. And again, this is just because 0.1 seconds or below is so fast that we feel this is something that is happening instantaneously. The next threshold is around 1 second. And this is where people start to feel, okay, it's okay. But now the button, when I press the button or interact with the system, there's something, I mean, I'm not in direct connection with the system. There's a latency, there's a gap between I send a command and the response comes back. And again, as I say, this is actually research done in somewhat the 70s or 80s. And today I actually think that maybe this 1 second rule is actually even less than 1 second today, because I've seen some of my junior engineers, when they search Google, I tell you 1 second is too long for them to wait on Google or web page to answer something. They will have closed the web page way before and used another web page. After 1 second, we get up to let's say 10 seconds, and this is where users, they generally get annoyed and really get annoyed. I mean, just think about the guy in the rain, standing out with his groceries, probably maybe even in a paper bag, like getting wet, and groceries will be all over the place if he cannot get inside the home. So when you get to around 10 seconds, the user really gets annoyed. And you can, of course, there's some systems where you cannot react within 10 seconds. And the normal kind of use case that is talked about in this case is, for example, servers that are looking for the correct type of flight tickets for somewhere. This can take more than maybe 10 seconds. And there's ways that you can then kind of make it easy on the user by showing a progress bar or similar. But normally you should try to avoid getting up on this type of latency. But as I'll show later on, even on the internet, I wouldn't say 10 seconds, but in the 1 second range could easily happen. This is a real life example. I've been out trying to research some smart locks out there from it's actually from a very big vendor. And this is the kind of response you get if the smart lock is not fast enough. So my story is not just something I conjured up. It's actually something you can go out. And if you take some of these IoT apps, you can find similar issues if you don't make it so that you can have responses happen within these thresholds that I just mentioned. So it's not just something made up in research or a story I tell. And basically also what these, if you read the research of these user experience guys, what they say is speed is just the overriding design criterion for any type of user interface. First, you have to make sure that you can accomplish the actions that the users the users, the requests that your users are issuing, you have to be able to make that happen within these time limits that I just shown. Otherwise, I mean, everything else, the color of the user interface and how much graphic you use, I mean, that's just doesn't matter. I mean, the first thing is speed. Fix your speed, then you can go and make nice colors and visual effects and everything. So again, if we then look at some of the IoT platforms out there and how is it with the speed and maybe also security on these type of platforms. And what we see, the type of platforms that is well known out there, because that was IoT kind of started, you can say, in the industrial, in the industrial side of things, and in industrials, it's a lot about collecting data. So this, you can say, cloud-based or database-based type of IoT has been very dominant out there for one reason being the industrial, but it's also something that is pushed by these cloud service providers. But again, you have an IoT device somewhere located at home or in an industrial facility, and this device produces data, but it can also actuate, so it can also service requests that some user could also be here. It's depicted as a human, but it could also actually be some kind of automatic system. But again, the IoT device produces data. This is sent up to a cloud application and stored in a database somewhere. If the user can then start up his user application. It could be an app, or it could be a browser interface, or whatever type of interface. And the user will then access this data using, you can say, the cloud application that will fetch this data from the database, and some kind of user interface will be presented. If then the user wants to, it could be the use case of a smart lock where he wants to open a smart lock, but it could also just be a thermostat where you want to increase the temperature because you can see that the temperature is getting below threshold, and it could be a summer house and you want to go out to the summer house and now you want to increase the temperature. What you do, you do not communicate directly with the IoT device. What you will do is that your request will be sent to the cloud application, stored in a database, and the next time that the IoT device normally will send up data, it will also ask the cloud application if there is data or requests to be done, and then it will fetch this from the cloud application. And this is also something that is sometimes called a digital twin, because what the user interacts with is not the direct IoT device, but instead a representation of the IoT device in the cloud called a digital twin. And of course, this introduces latency. And this is not the only thing that can actually introduce latency. This is some ping times that I have fetched from, it's 1 month old, but it's probably hasn't changed that much. But somebody called Wonder Network, they actually collect data. What is the ping time between regions on the internet? And here you can see that even if you have a direct connection between the user and an IoT device, you have actually in some cases, if it has to go cross a region, so from you have your servers in US and some of your customers are in Europe or could be in Asia to Europe or whatever type, so region to region, then suddenly already you are above the 0.1 second threshold for users. And this is before encryption and before everything else that will slow down the system. So servers, encryption, and so on. So if you have a cloud store and forward, this will only add up on this. And I already kind of touched it. Working with IoT devices, this will not be the only thing that will delay a request and response. I've tried to make a very simplified IoT stack here, where I say, well, we have an actuator, a sensor, then we have some logic, then we have a decryption, encryption, and then we have some network. And of course, you will have communication between these layers. And especially, well, not especially, but at least the two first logic layers is actually kind of hard on a lot of these small microcontrollers that you use for IoT systems. We have seen many systems where the network, for example, has been solved with UART. The communication, you can say, between the main microcontroller and the network layer has been connected with some kind of serial interface like UART, SPI, or I2C, or similar type of connections. And these are slow. I mean, it's 1 bit at a time, and even though it's running on the microcontrollers, many times running on somewhat fast bit rates, it is introducing latency. And the next thing, of course, is the encryption and decryption that you have to do. Of course, it will help if you have a hardware-assisted module that can encrypt and do encryption and decryption for you. But again, a lot of the systems out there today doesn't have this. We are starting to see a lot of hardware-assisted encryption and decryption on a lot of these microcontrollers today. But at least in the start, this was not present. So just the IoT device itself will probably also introduce at least 100 milliseconds or so of latency. And if you can get it down on 100 milliseconds, it's actually you're doing pretty good, I would say. Another type of IoT is what we call peer-to-peer IoT, or could also be called real-time communication IoT. Basically, what you try to do is you try to create a direct connection between the IoT client and the IoT device. And this connection is established via net traversal technology, which is basically the same type of technology that we are using here in Zoom or Skype or similar. Actually, the whole idea for this was based on why not use the same technology as Skype to communicate with IoT devices. And what you do is you actually traverse. There's methods where you can traverse the firewall. If some of you, if you know WebRTC, it's basically the same type of technology that is in there, and that is also something that we support today. So this is not just something that we have thought up. It's real-time communication is getting a bigger and bigger foothold in the market. Not only used for IoT, but also used for you can say human-to-human communication. But we'll see this also used in IoT. And you can of course say, why is it that difficult to create a direct connection on the internet? wasn't this the reason why we invented the internet, to make it easier to communicate from one internet entity to another internet entity? And yes, this was in the start of the internet, and I'm actually I was on the internet in the start, so it was part of my university time. So when I was studying, I'm actually a computer scientist engineer. And if you had an IP address for somebody's workstation, as they were called, basically a big PC that could both act as a server and as a PC. If you had the IP address for some friend's workstation on the other side of the world, you could actually create a connection directly to him, because that was how the internet worked. But this is not how the internet worked today, and that's because these internet worms were created, viruses that self-replicate and go from server to server and crash the internet at some instances in the very early part of the internet. So today, everything, there's a firewall between two entities if you start up today. And you can say, well, what about my phone? There's no firewall in front of that. And yes, there is. Your internet service provider, so the phone company, AT&T or whatever, they actually have a firewall for you present at their servers or their connection. So it's not easy to create a direct connection today, because you have these firewalls. And the next thing is IP addressing. So as I said before, if you had the IP address of somebody's workstation, you could connect to it. Well, today, this IP address is not even static anymore. Or mostly it is dynamic, delegated by the ISP. So actually, when your router, your firewall is rebooted, you might even get a new dynamic IP address if you have not paid. Today you can pay and get a static IP address, but that's normally an extra service that you have to pay for. So it's the main conclusion, or my main message here, is that this is not easy to do. But there are methods to actually do this, and what you do is that you coordinate that you are pushing out a connection from both sides, and if you know the IP address and the port that you are located on the both sides, you can actually create a connection. But this is not this is something that I could talk a whole webinar about how to do this, because it's if you're interested, you should go look up something called NAT traversal and NAT traversal techniques. There's even scientific papers on this out there on how to do it and how many firewalls will do this. So peer-to-peer or the direct connection doesn't solve all the problems that you will have. So just because you have a direct connection, so let's say if you go out and you read some of these papers, that's probably not gonna, it's gonna solve, you can say, some of the latency, but the next problem you'll run into is how do I secure this? And DTLS is a good way to go. It's basically the same as what you use in browsers, just for datagrams or UDP, the UDP network layer. And what you also you get the of course the fastest network path from A to C. And one thing is that you skip the latency of cloud servers, but also you have to remember, since you have a direct connection, not only do you skip the latency of cloud servers, but you actually also skip the communication cost of these cloud servers. Because if you relay through a centralized server, normally these server cloud providers, they will charge you for the communication or the amount of data that you transmit through these servers. So low latency, simple development, high privacy. Again, high privacy is because if you communicate directly from A to B, and you do not send it in clear text through a server, And normally, if you have a database, you will have to send it in clear text, get it stored in the database in clear text, and then send it out to the user in clear text. The issue is, I mean, who has access to these servers? If you instead create a direct connection, this is solved because the end user who communicates with his own IoT device, the data will be encrypted end to end. So data will always be on a device that the user owns himself. And for example, GDPR and the California, the CCPA, the Privacy Act, that is very similar to GDPR, does only apply if you keep private data on servers that is outside, you can say, the ownership of the end user. Yeah, and as I say, it's very, very scalable. If you centralize, as I say, another way to solve this is to centralize and relay data through a server. But this, of course, creates a centralized point where all the data has to go through. And at some point, if you have enough devices, you'll actually have to have more servers. But if you create a direct connection, I mean, you can transmit and you can reuse the device connections that you already have. And it doesn't matter if a user transmit gigabytes of data on this direct connection, because it's outside what you have to pay for. It's on the end user's own ISP account. Yep. Yeah, that was a very short, but also as promised in under 30 minutes. And I know Tarek, he wants more for the question and answer section here, but yes.
Yes, thank you, Karsten. That was great. Actually, can you see the chat, or I can read it to you?
No, please read it, because I have,
sure. Yeah, no problem. So the first question is from Somesh. And I think you maybe touched on it a bit, just in case. When it comes to security, managing the latency goes out of hand since the libraries use algorithms, which takes time. Do you think we can minimize it? His example is cryptography applications need enough time to complete its secure operations like encrypt, decrypt, and that's a must, of course.
Yeah. So what we provide in the IoT, the peer-to-peer or the real-time communication platform is most of this stack, including encryption and decryption. We use multiple different libraries for the DTLS. So we rely a lot on the DTLS standard, which is a protocol that is very similar to TLS, the one that is used for HTTPS or other type of it. Also, email is using TLS.
Yes, Karsten, he had mentioned DTLS 1.3.
Yeah. Yes. So we are not experts in, you can say, encryption, decryption. We just use these libraries, but a lot of times you can find a library that actually interacts with the hardware on a microcontroller. So you can use the encryption and decryption hardware assisted layer on a microcontroller, which is, as I say, something that, especially if it's a video surveillance camera or something that produces a lot of data, you definitely have to do, because otherwise, the speed will you will not even be able to send enough data to show a good feed from the camera, for example. But of course, another thing is the latency. So yes, encryption, decryption is a thing. If you go out, you should definitely use something that has easy access, so that you can find something that attaches down to the hardware assisted layer on your microcontroller. And this is also why we are not trying to invent something ourselves in this, because there's a lot of people out there doing doing these libraries that is compatible with the DTLS, so it implements the DTLS layer, but also it does it via using the hardware on the different type of microcontrollers.
That's great. So Vic has a question. What does Nabto provide for IoT? Obviously, Vic, Nabto provides a secure platform that can help you secure and speed up your IoT connection. I don't know if you want to add something to that, obviously, but this is definitely our expertise, Vic.
Yeah, maybe this I can see I don't have the but maybe this is probably the best slide for that. I do have some supporting slides. This is what we provide. Basically, the orange boxes is what we provide. So we provide something called base station services, which is pretty much the same thing that is underneath Skype and Zoom and there's this you can say it's something that coordinates creating these direct connection. But once these direct connection then are established, the base station is out of the scope. And that so we have SDK software development kits for creating these client applications. So if you want to go create an application on your smartphone, so Android or iOS, we have a client SDK for that. Then we have software that go on, you can say the IoT device, what we call Nabto Edge embedded SDK, which is pure C code. You of course have to create, there's an adaptation layer that you have to implement, but we have implemented it for the most type of systems out there. So it should be, I would say, straightforward. Nothing is straightforward in embedded device software implementation if we have embedded engineers out there. But it's we haven't found a system yet that we could not put our software onto, because mostly this embedded devices they come with a C compiler. So this is basically what we provide, all these orange boxes to make these direct connection possible, secured with public PKI, public key infrastructure. So you are 100% certain that the device is who you want to. So the smart lock, so when you connect to the smart lock, you know that it is the smart lock, that you're the right smart lock you're connecting to. The smart lock will know that it is the right user with the right authority that opens the door. And I don't know how much people know about PKI, but it's the same thing that you use in network banks and similar. So it's kind of the highest level of security that you can get on the internet today, without special, I don't know, maybe there's some quantum encryption, something, but then we are definitely out of IoT cost scope.
That's great. So Vic, just to follow up on your second question, do you integrate the full IoT system for a customer? Yeah, we definitely do.
Yeah, normally we help people do it if they have an internal development. If not, we have a bunch of partners that can assist you integrate it on your IoT device. We mainly ourselves, as I say, we do support customers doing this, but we don't have you can say internal consulting services that you can buy, but we have partners for that. So we have partners all over the world that are experts, and it of course also depends on which system are you on. Is it normally today IoT devices either run Linux or they run a real-time operating system, and there's a big difference between FredX or Microsoft real-time operating system and Zephyr or FreeRTOS. So you also need to find the right partner that actually has experience in the type of IoT platform that you wanted to integrate to.
Thank you, Karsten. So Serhi has I just want to add real quick that we have helped, we can't mention certain names, but we've helped a lot of large Fortune 500 companies with this exact challenge. And so it's definitely our specialty. Serhi is asking, in your example with the cloud platform, the cloud introduced the latency. but in fact, there might be also some business logic, for example, data analysis made in the cloud. How using the Nabto platform can you keep the business logic running while having the direct connection?
Yeah, I would say, let me see if, oh, now it ran out here. Sorry, I'm flipping through the slides because I'm now this is a down compiled slide set, so I don't have the slide that I want to show, but let me show this one and just this one. I would say that what we see mostly is that is actually that people it's not a question of the one or the other. What we see a lot of our customers do is actually they have a cloud application that stores data, and for example, in the smart lock, we have smart lock customers. We have a very big German smart lock customer, and we know that they use Azure to store who has opened the door, when did they open the door, and all kind of, you can say, log from these action that has been done on who did it and when did they do it and why did they have authority to do it. They store this in Microsoft Azure in the cloud application. But the direct access and the direct communication to the smart locks are handled by our software. So I'm not saying that you shouldn't have a cloud application. I'm saying you should think about what is the appropriate technology to use for the, you can say, the actions that you send directly to the device, and the actions where you say, well, this is for long time storage. Maybe it shouldn't be on the IoT device. It should maybe be in the cloud. And now you can also do analytics and some business logic on it. So we see ourselves as something parallel, you can say, to cloud system, not something that should replace a cloud system. Hope that was understandable. So yes. I don't see the I mean, if you have business logic in the cloud and this cannot be transferred to the IoT device, you should just keep on having that in the cloud. But you should definitely think about when clients do direct actions with the device and direct communication. One thing I haven't even talked about here is, let's say you on a local the local internet. So at home, if you have a device installed at home, you'll have a small internet, Wi-Fi based or Ethernet based at home, and then you have, of course, a router going out to the real internet. If you lose, you can say, the connection because the ISP for some reason has a breakdown or something just shortly. If you are totally dependent on a cloud application for communicating with your IoT device, even if you are at home, you're on the local network that you have at home, your IoT device is on the same network, you will not be able to communicate with this device unless, of course, you do something alternative to the cloud application. So this is also a good reason that you should think about having this real-time or peer-to-peer IoT for communicating directly with the device, because in our case, if you have two devices on the same network, they will be able to communicate. It's also securely because we still use PKI on a local network to authenticate people. So again, there's so many reasons for both having a cloud application for long-time storage of data, and then you have something where you communicate with the IoT device. That's probably the conclusion of all the things I've said. So the last 5 minutes, sorry.
Thank you, Carsten. Sir, he says thanks.
Yeah, no problem. Yep. Yeah, no problem.
I just wanted to ask you, so you've been doing this for a while, but have you seen more of an uptick in companies wanting to secure and speed up their IoT connection more recently than previously before?
When companies, they start to get these, as I showed, when they start to get these reviews saying, okay, this is too slow. And I think it's a natural way to this has happened, because I mean, in the start, I can remember when the first IoT devices got on the internet. I mean, it was incredible. You could now communicate with a device. That didn't matter if it took maybe 2 minutes for the command to go from A to B, because I mean, we went from not being able to communicate, now we couldn't communicate. So even, I mean, very long delays was okay, but humans, I haven't any research, but humans just want more. And at what I see today is that people expect the same type of, you can say, latency or service requirement that you see from normal apps that you have on your phone. They want to see that on the IoT device, and end users, they cannot distinguish and say, okay, this IoT device is running a small microcontroller and the data has to go up in the cloud. They'll just say, this, I have an app for my IoT device and I have an app, I don't know, Snapchat, or I don't know what type of apps people have on their phone. And they'll just say, well, this is an app and this is an app, and I expect the same type of user experience on those apps. So yes, we do see an uptick in people interested in how do I cut down on this delay from the cloud applications.
Yes, yeah, this is the evolution. It's a next step in IoT.
Yep. And I guess, as I say, it's natural because you started out, even I saw some of the early system was not even internet-based. It was some codes that you had to send on SMS or text, you know, the text where you had complicated codes that you had to send. And people were okay with that because the alternative was that they had to go to the summer house to turn on the heat or something. And now that at least if they sent the right code, they could activate a thermostat or turn on a lock or whatever the use case was. But again, as I say, people, they are just getting the demands for you can say very high responsive applications is just it's just natural.
Yeah, that's great. That's great. Well, this is a lot of great information. Thanks again, Karsten. Thank you guys for all the great questions. What I'll do is I'll make sure to follow up and email everybody this recorded version. Our pleasure, Lewis. Thank you. I'll follow up and with a link to this recorded webinar so that you guys could keep it and use it as needed for the future if you want to take a look at it again in the future. Okay. Any other questions from anybody else? All right. Karsten, thank you, everybody. Thank you, Karsten. It's been a pleasure.
Thank you.
And if you guys have any questions, please feel free to email me. And if they get pretty technical, those questions, don't worry. We can find the answer out with Karsten and the team as well. So just let me know. Okay.
Great.
Thank you, guys.
Thank you very much.